Hello and welcome to another video lesson with Mr. Roman. Today we're going to be talking about how to determine whether a triangle in the coordinate plane is a right triangle or not. So first we need to know a right triangle is a triangle that has a 90-degree angle in it. So this would be an example of a right triangle. And really, when we're thinking about finding a right triangle in the coordinate plane, we're going to need to find if two of the sides of the triangle are perpendicular to each other. So remember, perpendicular, so perpendicular, okay, perpendicular. This means that two lines intersect at a 90-degree angle. Okay, so two lines that intersect at a 90-degree angle. And the symbol for perpendicular is an upside down T like that. And anytime you see a symbol with the box like this, that indicates that you have a 90-degree angle at that intersection. So, how do we determine if two lines or two segments are perpendicular in the coordinate plane? So here's an example. We have what we see as a coordinate plane here, the x and y axis. And let's say we had two lines that intersect like this. Okay? What we want to know is, how do we determine whether this is going to be a 90-degree angle? Well, the way to determine that is to determine the slope of this line and the slope of this line. And if the two slopes are opposite signs, so one being positive, one being negative, and the slopes are both reciprocals of each other, then the two slopes are perpendicular, or in other words, they form a 90-degree angle. So let me write that out more thoroughly. Slopes that are perpendicular, so perpendicular slopes are opposite signs. So opposite signs meaning one's positive, one negative, and they are reciprocals. Reciprocals of each other. And what does reciprocal mean? Well, reciprocal means that you take whatever fraction of the slope it is and you simply flip it. So 1/3 and 3 are reciprocals. If this were a negative 1/3 and a positive 3 slope, these two would be perpendicular slopes. If it's 3/4 slope negative and then 4/3 slope positive, these two would be considered perpendicular slopes. So these two lines form a 90-degree angle. These two lines form a 90-degree angle. Let's look at a more concrete example in the coordinate plane itself. So, in the diagram, you have a picture of two intersecting lines, line K and line M. And if you look closely, they seem to be crossing each other at a 90-degree angle. But there's no way to be certain unless we know the slopes of line K and line M. And again, if those two slopes are opposite signs and are reciprocals of each other, then we can determine whether they are perpendicular, or in other words, a 90-degree angle. So we want to count the slope between line K and M, and in this case, the slope of line K is going to be negative 2/3. The slope of line M is going to be a positive 3/2. So the slope of line K and the slope of line M. The way you find slope is by using really the slope formula or counting boxes. If we were to use the slope formula, we would take 2 points on the line and In this case, we had the point 2, 4, 6, so we had points of 0, 6 and 3, 4. So 2 points on line K were 0, 6 and 3, 4. 2 points on line M would have been 1, 1 and the point 3, 4. So again, looking at the diagram, 0, 6 would be this point here, and then 3, 4 would be this point here for line K. For line M, 1, 1 would be this point, and then 3, 4 would be this point for line M. And we're going to calculate the slopes of those lines. So line K, we're going to say the slope formula is y1 minus y2 over x1 minus x2. And in practical application here, what that means is we can say y1 minus y2, so 6 minus 4 on the top, 6 minus 4 on the top, and then on the bottom, 0 minus 3. So we went in this order for the top, so 6 minus 4, so we have to go in this order on the bottom, 0 minus 3. And here we can simplify and see that we're going to get 2 over negative 3, which yields a slope of negative 2/3. Here, if we use the slope formula, y1 minus y2 all over x1 minus x2. Here we can see y1 minus y2, so 1 minus 4 is going to go on top. So 1 minus 4, and then 1 minus 3 on the bottom. So 1 minus 3 on the bottom. So here we're going to say negative 3 over negative 2, which actually a negative divided by a negative is actually a positive. So here we have the two slopes as negative 2/3 and positive 3 over 2. They're opposite signs and they're reciprocals of each other. So in fact these two lines M and K are reciprocals of each other. Therefore they're going to create a 90-degree angle between them. So, when we're dealing with triangles, for example, the triangle here in this diagram, we want to determine whether this is going to be a right triangle. And if you look at the segments AC and CB, they seem to be intersecting each other at a 90-degree angle. But the only way to be sure is to calculate the slopes. So, we're going to use the points A and C to calculate the slope of segment AC, and then the points C and B to calculate the slope of segment CB. So let's put those points, those coordinates up on the whiteboard here. So the coordinates of point A was negative 2, 8. Coordinates of B was 5, 4, and coordinates of C were 1, 2. Okay? And again, we wanted to find the slope of AC and then the slope of CB. So remember, the slope formula is y1 minus y2 all over x1 minus x2. So on the top here, for AC, we're going to say 8 minus 2 on the top. 8 minus 2. And on the bottom we're going to say negative 2 minus 1. So negative 2 minus 1. On top we'll get 6, on the bottom we'll get negative 3, which reduces then to a negative 2 over 1. Then for CB we're going to say y1 again minus y2 over x1 minus x2. So here we can say y1 minus y2, so 4 minus 2 on the top, 4 minus 2, and then x1 minus x2, so 5 minus 1 on the bottom. On the top we'll get 2, on the bottom we'll get 4, which reduces to a positive 1/2. So the slopes here of AC and CB, the segments, really we should have segments here, segment indicator, they're opposite signs and they're reciprocals of each other. So in fact, AC, the segment AC and the segment CB are perpendicular. So we look back at our diagram, the segment AC and the segment BC are in fact perpendicular. So we could draw a 90-degree angle box symbol on that triangle. And we have just determined that that is in fact a right triangle. This concludes our video lesson.